Let's look at number 14. In question number 14, it says a soccer coach wants to divide a large field into 4 rectangular regions for a drill. These are 4 equal rectangular regions. He has enough chalk to mark out a total of 180 yards. Let X represent the length of one of the smaller rectangles and let Y represent the length, it should be, of one of the smaller rectangles. We want to express the width in terms of X. So the width is Y. We want to set Y equal to something in terms of X. So I came over here, and this is what I've drawn in order to model. So this is Y, 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 and X, X, X. 1, 2, 3, 4, 5, 6. So 6 X's. 1, 2, 3, 4, 5, 6 plus 6 Y's equals a total of 180. Now it asks us to express the width, which happens to be Y, in terms of X. That means solve for Y, or isolate Y, I should say. 6Y equals 180. Subtract 6X, divide by 6, divide by 6. The 6 must be shared with both the 180 and also with the 6. Now 180 divided by 6 is 30, so 30 subtract 1X. That is part A. We just represented the width in terms of X. Let's come back to this picture. Express the total area in terms of X, the total area. So as a function, so you need to have A of X. So A of X equals, let's do one rectangle. So X times Y, and then there's 4 of them for the total area. But we want to express it only in terms of X. That means we're going to replace the Y with 30 subtract 1X. Let's go back and see what we need to do for part C. Calculate the area of a smaller rectangle. So calculate the area of a smaller rectangle, not the entire thing, a small rectangle when X equals 5. So we only want to know what one of these are. We only want to know what one of these are. And we know, oh shoot, I forgot what it just said. When X equals 5. So we know X equals 5. So when we know X equals 5, what is this area? Well, we know Y is equivalent to 30 subtract 1X. So we're able to go, okay, this is 5, and when I replace 5 over here, 1 times 5 is 5. Whoops, so sorry, I forgot to flip back. This length is 5, as we are told. This length is 5. And now we need to know, what is the width? Well, the width represents Y, 30 minus 1X. We know X is 5, so 30 subtract 1 times 5. 30 subtract 5 is 25. So the area of one of the smaller ones is 5 times 25, or 125 is in terms of yards, square yards. Let's look at part D. Calculate the maximum area of the large field, which is all 4 combined. So what I will do is I will come back here and take this equation, and I'm going to plug it into my calculator simulator. So I'm going to come up here and clear this, and plugging this in, we have 4 times X, oops, times F, so let's do this again, 4 times X times Y, which is equivalent to 30 subtract 1X. And now I'm going to approximate what I think this may look like. Let's go 0 to, I'm just going to take a guess, and I will definitely adjust this. Let's do zoom fit. We can probably even take that back a little bit. Let's go down here and make this 30, and let's see if that's appropriate, if I can see everything we need to see. Perfect, I can see everything. We want to know what is the maximum area. I want to make sure that's correct, what we wanted to do. What is the maximum area? That is part D. So let's come back to this. I want to know, what is this Y value? So second, trace maximum, which is number 4. I'm going to go somewhere to the left here. So somewhere to the left, let's try 10. And then somewhere over here to the right, let's try 25. And then I press enter one more time, and there we go. I'm going to write this down. So at the very height of this is X equals 15 and Y equals 900. X equals 15, Y equals 900. We got to make sense of that. So I have right here is 15 and 900. Remember, X represents the length of the smaller rectangle. So when the length of a small rectangle is 15, the maximum area is 900 square yards. Let's go to the next one. The next one says, part E says, what are the dimensions of the maximum field. So they're saying the dimensions of the maximum field. Well, we're going to get the dimensions in terms of a small rectangle, but we could also do it in terms of a large rectangle. I think they should be specific so we have a better idea. So we know that the small rectangle, this is the x, has a length. So a small rectangle has a length of 15. Now, how do we figure out what the width is? Well, the width is y. So when I plug in 15, 1 times 15 is 15. 30 subtract 15 is 15. So this is 15 by 15. So you need to specify and say one of the smaller rectangles has dimensions of 15 by 15. Or 15, 15 is 30. 15, 15 is 30. Or you could say the large field has the dimensions of 30 by 30. But you need to specify, is it the small rectangle or the combined large rectangle that you're giving the dimensions of? I think that could have been worded better and more clear for you. State the domain. So to figure out the domain, we want to know from 0 to what? I want to know what is this value. So I'm going to go second trace. I want to figure out the 0. And so somewhere to the left, I'm going to say 25. Somewhere to the right, I'm going to say maybe 31. It goes outside. I don't know if it's not going to let me do that. Let's extend this so we just have a little bit better view here. Let's go out to 40 and do a zoom fit. Okay, now second trace, let's figure out the 0. So I'm going to go somewhere to the left. Now if you like to move it closer, you can do that. And then somewhere right below, and then back to guessing. And it goes from 0 to 30. 0 to 30. So here is 0, here is 30, and it's in terms of yards.